Hello, this is Mr. McGovern, and this is the second video in the acceleration series, and we're looking at graphs, using graphs to describe accelerating objects. So we're going to start by describing our object with a motion map, get into some graphs, and then look at how gradient and area can be used for calculations. So here we have a car accelerating from 0 to 20 meters a second over 4 seconds. So I've displayed that using a picture taken every second of the car. You'll notice that the distance between the pictures of the cars increases as the car gets faster and faster and faster every second. So motion maps, what we've added first, there's a coordinate system. I've chosen it to point to the right. You can see the velocity arrows are getting bigger and bigger, and acceleration arrows go in between velocity arrows. The acceleration points to the right, and it looks like the acceleration is equal in this case. That's why I've got those little equal signs on it there. So my velocity is increasing and my velocity is positive because it's pointing in the positive direction according to my coordinate system I've chosen. The acceleration is constant. Okay, it is accelerating, but it's the same acceleration each second. And that's also positive because it's pointing in the positive direction. Okay, so let's draw the graphs here. The first one's the position time graph. Because the object's accelerating, in the position time graph you get a line that gets steeper and steeper and steeper every second. Its velocity time graph, we know the velocity is increasing and it's positive. So I need a line that starts at 0 and gets bigger and bigger and bigger towards 20 meters a second. I can put some numbers on this graph because I know the numbers from the question. That's going to be helpful soon. Acceleration, the acceleration is constant, so the acceleration, whatever value it is, doesn't change. So what that's going to look like is a horizontal line on the graph. It's also positive. That's what the acceleration time graph looks like. Right, so moving between these graphs is the skill we really want to pick up in this video. If you start with a position time graph and you wanted to look at any point on that position time graph and you say how steep is that line, that'll tell you the velocity at that point. And so if you were to do that at every single point on your graph, you get enough information to be able to draw yourself a velocity time graph. The same is true for getting from velocity to acceleration. If I look at the gradient of the velocity time graph, and our velocity time graph only has one gradient because it's only one steepness because it's a straight line, that tells me all about the acceleration. I can move back the other way. I can move from a velocity time graph back to a displacement, and the way I do that is the area under the graph. I'm going to show you how to do that in a second, and the same is true from acceleration back to velocity, is the area under the graph. So if you drew your position, velocity, and acceleration like this, moving from one graph to the right of it, we take the gradient, and then moving back to the left, you'll see it's always taking the area. This is calculus. You've probably heard of calculus, and it's something you study in school. This is what it is. It's being able to move between these different types of graphs. And in one direction, you're taking the gradient of the graph, the steepness of the graph, and moving back the other way, you're taking the area under that graph. So let's do this using an example, and hopefully it'll make some sense. So I want to look at the acceleration, and I want to start with my velocity time graph. And I've told you that the gradient of that is the acceleration. So gradient, the way you calculate it in maths, is rise over run. So in my velocity time graph, my red line rises by 20 meters a second and it runs by 4 seconds. 20 divided by 4 is 5. And look at the units. I've got meters per second, and I divide by another seconds, and that gets me the units of acceleration, 5 meters per second squared. So I can now put that value on that graph because I know what the acceleration is. I can move from my velocity time graph back to my displacement. And to do that, I work out the area under the graph. So my velocity time graph, the area under that graph is actually a triangle. So I'll shade it in now. So that's what I'm trying to work out here. What's the area of that triangle? The way you work out the area of a triangle is a half base times height. The base of my triangle is 4 seconds, and the height of my triangle is 20 meters a second. Multiply all those together, and you get 40 meters. That's how far my car goes in that 4 seconds. So now I can add that to my position time graph. So now I've got all the information I need about this car. So I haven't used any equations yet, I've just used the graphs. Very powerful. So once again, you've got your summary. Moving between the graphs, you're either using the gradient of one graph to find the next one, or you're trying to find the area under one of the graphs to move back to the other. In the next video, we'll use the equations to basically solve the same thing.